Okay, this video is on the rational zeros test. It starts on page 243, and this test says if I have any polynomial and all I'm looking at is the rational zeros. Now you have to keep in mind a rational zero is a number that can be written as a fraction. So the square root of 2 could still be a 0, but this test will not tell us that that's a possibility, okay? However, this does eliminate, again, some possible things. So, possible rational zeros are equal to the factors of the constant term over the factors of your leading coefficient. Leading coefficient would be the number that is in front of your largest coefficient. So if it's x to the fourth, then I'd want to look at x to the fourth's coefficient. And that's literally all you do, and it will give you a list of all of the possible rational zeros. So let's do two quick examples. And what this test is going to allow you to do is, again, eliminate some possibilities. So here's my polynomial. To list all the possible rational zeros, I want the factors of the constant term. Well, that's 16. So on the top, I need factors of 16 over leading coefficient, that's x to the x cubed, x to the third power, that'd be 1. So that's nice because factors of 1 are just 1. So that would be plus and minus 1 and plus and minus 16. Plus and minus 2, plus and minus 8, and then plus and minus 4 are all the possible factors of 16. And then we have all over 1. So possibilities, we do 1 divided by 1. So we've got plus and minus 1. 2 divided by 1. Plus and minus 2. Plus and minus 4. Plus and minus 8. Plus and minus 16. And that would be the result of the rational zeros test. Then I would be able to use synthetic division with these numbers to see if one of them is a 0. So let's do one where this bottom isn't 1, because that's pretty easy when you have a coefficient of 1. Again, these are not all of the possible ones. We know this one can have at most 3 real zeros, but here's some possibilities. So we've got 6x cubed minus 71x squared minus 13x plus 12. Make sure you don't get these backwards. A lot of times people will put factors of 6 over factors of 12, but that constant goes in front. Factors of 12 over factors of 6. All right? Plus and minus 1, plus and minus 12. And you certainly don't have to write yours like I do. Just make sure you get them all on there. Okay. And then factors of 6. All right. Now this one is a little bit more difficult than the one we had above. So what I do is I use each number in the denominator with each number in the numerator, and I just make sure I don't repeat anything. So everything is over 1. All right, and then I go ahead and cross off that 1 because we've already taken care of that. Now, everything is over 2, so plus and minus 1/2. Okay, now I'd be doing 2 divided by 2, which is 1. 3 divided by 2, I don't have that one on there. 4 divided by 2 I'd already have, 6 divided by 2 I'd already have, and 12 divided by 2 I would already have. So I cross that off. Then I need to do 3, 1/3. And this is nice because you can't tell these decimals or fractions directly from the graph, but it gives you an idea of where to look. Then we've got plus and minus 2/3. 3 over 3 would be 1. 4 over 3 I need to add. 6 over 3, 12 over 3. So 3 is done. Then I've got plus and minus 1/6. 2/6 would simplify to 1/3. 3/6 would simplify to 1/2. 4/6 would simplify to my 2/3. 6 over 6 would simplify to 1, and 12 over 6. So there are all of my possibilities of rational zeros. So that's it for the rational zeros test. Just make sure factors of the constant term or factors of the leading coefficient, and then these are possibilities, which if I look at a graph and I say, oh, well, that looks like it's a little more than 1, then I know it might be 4/3 or it might be 3/2, and then what we're going to do is use synthetic division to figure out which of those it might possibly